Hello. This activity is all about capacity and containers. It's called bottles and capacity. And apologies for late start. There was a leaf blower going, so I couldn't start because it was too noisy. So what you want to do is go and get containers. I've got all these. I'm keeping this open right here just for now, so that I've got all different kinds of containers. Different cups. I've got containers. Some show their capacity and some don't. A mug, cup. I've got different teaspoons and spoons. I've got some other. Oh, look, there's this container itself. I wonder how much that holds. Oh, I'm not going to show you. And I've got some fairy liquid. I've got a litre bottle here. And then I've got a big kettle. Oh, super heavy. Not even going to lift it up. So let's have a look. See if we can go there, get that one started. And now this one's here. We are going to see if I can find, oh, here we go. See if I can share that. Make a watch party if we're lucky. Here we go. And then I'm going to put the computer over to one side because, well, Leo isn't here this time, but we had I filmed Leo last night, so that will go on YouTube, and that hopefully will stay there and stay dry. So what are we going to do? We are going to start with an activity for, well, the activity is, we've got water, we've got collection of jars and bottles and all different shapes and sizes. And so we want to know, we're looking at this, which one holds the most? Which one of these, is it the kettle? Is it this pot here? Which container do you think here holds the most? And of the things you can see here, which ones hold the same amount? Which of these do you think hold the same amount? Let's have a go. And then what else have we got? How can you find out? How can you find out which container holds the most? Now, we're going to start by putting all the containers in order from what we think might be the least to the most. I'm going to go here, and if you find, now I've got, I don't know if you can, let me see if you can see. Let's see. So I've got to be able to see what you can see to make sure you can see what I'm doing. So I think, now I might be wrong here. And I'm not going to look at the sizes on the jars. I think this is the next biggest. And then I think, now I did do a bit of investigation last night, so I do have an idea about these. I think, but I didn't investigate them all. I think these two might be the same. Don't know, these two might maybe the same, I don't know. I don't know which of these, I'm guessing. I think this might be like this. That could be smaller, I'm not sure. This one here. Whoopsie. Oh, we've got the spoons. The spoons are quite small, aren't they? Should we put all them in there? Is that the smallest container? Whoa, we've got all kinds of different shapes and sizes of spoon there. And we've got this one. I don't know which of those two is bigger. I think this one is smaller than that. And I think this one is, I don't know which of these two is smaller or bigger. This one might be the same as that, but I don't know. I think this might be smaller. Can you see? Oh, you can't see. Right. So I'm going to bring it round, lower this down a bit maybe. Ooh, without. Ooh. Okay, there we go. Now, what can you see? Put it further away. Can you see everything here? Oh, that's better. You can see all of that there. I think this one might be smaller than that. And then this one. Maybe it's the same as that one. Maybe it's bigger. I'm not sure. Where does this one go? I know this is a liter. So maybe here without reading. And then this one may be bigger than that one. And this one maybe also maybe about the same. I don't know. It's pretty big looking, isn't it? Maybe it's the same as this. All right. It's all guesses. Now here's a question. How many times, let me see, we're starting with 7 to 11-year-olds. How many times do you think this bottle would fill this glass here? How many times do you think? Let's have a go. Let's see. What is your guess? There's one. We're filling it all the way to the top. We'll put it in there. Ooh. 2. And then if you can write notes down, make a note of 2, 3. How many do you think? You can change your estimate. Whoa. I thought you finished. 4 and, oh, there's a little bit there still. Okay. So that's 4 and a bit. Now I hope you can hear me. So now this I know is a liter. Now, can I measure a liter with any of these? Because I want to actually make sure that I'm actually working with the liter here. So, because we usually fill this up to about here with nice fresh orange juice. Is that a liter? Are we getting a liter? We need to check and see if we're actually getting a liter whenever we go and get our orange juice. Let's see, let's measure it on this one. Now, if we fill it up to here, we have 500 milliliters, and it costs €3.20. Well, I'll leave that there, which I've just gone and bought it to do this. And so that's, well, let's see if you can think how much 500 milliliters is. Let's have a go on here without spilling it. Whoops, I've spilt some of it, so it's not too accurate. I've spilt some of it. We have to bear that in mind. That's half a litre. Now wait, half a litre only goes up to here. And there's an awful lot more bottle. Observe the shape of the bottle. Let's see what you think about how high is the litre going to be. Let's see, another 500 milliliters. 500 milliliters. Oh, look, there's some left over in here. Let's have a go. 500 milliliters. Oh dear, let's put it in there so we don't waste. Waste not, want not. 500 milliliters with a little bit spilt. Whoopsie, maybe a teeny bit. We need to add a little bit just to compensate for the spillage. I'm going to just eyeball it about there. So that should be about a litre. So there's, when we fill it up to there, we're getting more than a litre. So we're getting that much orange juice for free. Now, I don't know what the shop feels about that, but that's certainly what my grandson says. We have to fill it up to the top. Well, we don't fill it up right to the very, very top, because otherwise we'd spill it, and we don't want to waste orange juice. So that is a litre. And we had this extra water in the top. Now that we know how much a litre is, what other containers do you think we can fill up with this? Do you think this and this look about the same? This one's going to be fun because, where am I going to put this excess? Oh, well, never mind, we'll just, no, because there is some excess there. Well, we're just going to pour it on here. We've got a rag in here, that's fine. There we go. This one's going to be fun because can you see what's in there? Yeah, got some soap in it. So we're going to fill this with a litre and see if it's a litre. What do you think? Is it a litre, less than a litre, or more than a litre to fill this up? Let's have a go. Let's have a go. Woo. Maybe we should do it over a bowl as well, eh? So we don't waste it. And then you can't see. Well, we can pull it out. Remember, half a litre was about there, wasn't it? So let's put half a litre in. See, whoa, see what happens. We're just pouring it in. Something's coming out. What's coming out of there? Whoa. Let's see, we've got to half a litre yet. No, a little bit more. If you do that, you can mark where everything is and what's half a litre and what's a litre. Okay, well, that's about half a litre, isn't it? We can check. We can check if it's half a litre by pouring it into there. Ooh, just a little bit less. Doesn't quite come up to that line. So that's half a litre. You can't see that. Let's move it back over here. That's half a litre there. And this is half a litre up to here. Now, do you think we can put another half litre in there? See what happens? Let's have a go. Displace the foam. Woo, that's fun. Check it out. Oi, boing, 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 boing. That's lovely foam coming out. Thought you'd enjoy that. Thought I will use that. I won't rinse it out completely because we've got lots of lovely foam coming out. Half a litre. We're going to be able to fill it all up. Oh my goodness. Okay, that's interesting. That's very interesting. I've got to check that now because on the back here, it says 820 millilitres. Now, a litre is 1,000 millilitres. So now I'm a little bit befuddled. Let's see. Let's just test that again. I was expecting it to go way over the top. So it could be that we've lost some water because of the foam. Because of the foam coming out, it might have displaced some water. That's 500 millilitres. We'll pour that in here. That's 500 millilitres, and let's see how much the rest. So 500 millilitres came up to here, but that's, well, I don't know. Is that half full? Is that 500 millilitres? Oh my goodness. So we lost all that water because of the foam. We lost loads and loads and loads of liquid in there. So we're not going to keep using that foam because it's causing our measurements to not be accurate. So let's see if we can now measure it properly. Let's put a litre in there, shall we? So let's get this up to a litre. Let's put non-foamy. There we go. Half a litre. Fill that up with half a litre. See if we can get it right this time. Oh, we are losing some though, aren't we? Oh, that's right. We had it in there so you could see. Half a litre. Let's hope it all goes in this time. Stay inside. Stay inside. Just goes to show with soap, your measurements are not going to be as accurate. You need to keep all the excess liquid so that you can then measure it accurately, because we don't want to. Accurate measurements are super important. I'm having fun with this water, with this soap. Okay, so now we're going to take that soap and we're going to get it in there as well. There we go. We won't want to miss any water. We're going to miss any liquid. Now, I'm going to fill that up again. Another half a litre. That's half a litre up to there, look. Can you see? Oh dear, I'm holding it up. You're down there. Half a litre up to there. Now. Look. Oh, it's all spilling out, look. Well, we'll just go ahead, let it spill out. Let's see if we can get rid of the foam and then we'll pour it back in from the bowl. Because the liquid's all going inside the bowl. So it's all spilling out, lots and lots and lots of it is spilling out because of the bubbles. And then what we can do is, look at that, we've filled it to the very, very brim. And now let's see how much liquid we had, how much excess liquid we had. Look at that. So this container holds less than a litre, and you can see how many milliliters. And if you do that without the foam, then you'll get more accurate measurements. Okay, next, right, this one we've worked out what a litre is. Now this one, how big is this one compared with a litre? Let's fill this, which one's going to be bigger? This one or that one? Let's see. Let's get a litre into this jug. 500 milliliters. Let's pour it in. Wait, we don't want to lose water. There we go. It's not all going in. Some of it's going on me. That's why I'm doing this outside. And then another 500 milliliters, but we're going to put a little bit more in because I spilt some of it on me. I'm getting nice and wet here. Whoa. Okay, we're still spilling some. Whoa. Well, okay, we'll make that a litre. Now, I think it's a little bit more than a litre. Let's pour it in here and see how high we can fill this up, or is it going to spill over? What's it going to do? You see that? Now I think we've got more than a litre in here. So what we're going to do is we're going to do it slightly differently. We're going to use the measuring jug to measure it, to see if exactly how much, whoopsie, how much we've got in there. So, right in there. And I think I'm having too much fun. I think that's the problem. Put that in there, let's have another go. Right, so half a litre, we're going to get this right. Measure it accurately. Get that up to half a litre, which is there. Right, let's do this right now. Half a litre into here. And another half litre that we measured out into here, and we have, it's nearly a litre. When we did it last night, we came up with a litre. So we'll see. But anyway, it was about the same amount of liquid in here as fits in here. So now we're going to pour that in there. And this holds about the same amount of liquid as this. Which did you think would hold more, this or this? So there's another one. Now, let's see what else we've got over here. Well, this was an interesting one. We did this last night. And let me get it right. This one here holds 2.5 litres. Let's fill this up to its 2.5 litre mark, which is over here, 2.5 litre mark. Let's put them. Fill this up to the 2.5 litre mark. Now, we got any more water? Oh dear, 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 dear. This was really cool. Oh, here we go. We've got some more down here. Up to 2.5 litres. That's pretty much full. Now, which one holds more? Ooh, got some foam in here as well. This one or this one? Which will hold more? Can you see that? Which one will hold more? This one or this one? Let's have a look. It's 2.5 litres in this one. Carefully pour it in. Make sure none of it spills out. For a change. And all the way to the top. Check it out. It's brilliant. And then we can get the foam. But I don't recommend the foam. The foam, I wanted to demonstrate that even though these two bottles look like they're the same size, sorry, they're not. But because they were still foam, I thought it'd be fun to play with the foam, but it is actually affecting the accuracy of the measurements. All right, let's go down to some more detailed bits. So that's what we're doing with, I've got my computer here. So far it's dry, we're doing all right. Got my computer down here, and so that's a bit of fun, just test. See if you can find ways of counting how many different containers fill all the other different containers. You don't have to talk in litres and milliliters, especially the younger you are, the more you'll just count containers, and we'll do that with the early years in 29 minutes. Now, you can start with just 2 containers. Now, let's see, we're going to start with, there's stuff in here for older, maybe not 18 plus, depending. Let me see, what have we got? Diagnostic quiz. The quiz says, well, I'm actually going to let you do that. I'm going to let you, in the activity pack, in the activity PDF it's in the description above, start with, if you're 7 to 11, start with what's called the Diagnostic Assessment, which is an awfully big way of saying it's an activity to do. Start with that one and then start playing with the bottles. This is after we finish with the live. Now, the next thing we're going to do is we're going to move over to slightly older learners, and this does go up to 18 plus, actually, looking at it. So we're going to start looking at more accurate measurements, and let me see if I can see what you're saying. I just want to raise it up a little bit, teeny tiny bit, because there. Now, we're not going to use the big containers now. The big containers, we can use the big containers, but it's going to go into a little bit more detail now. So there's an activity in there, in the activity pack, where you're looking at volume, and you're looking at the difference in different types of volume. Like, for example, something that's tall and thin, how that compares with the volume of something that's rectangular, or something that's, how many of these, for example, would it take to fill one of these? Actually, that's a nice one. How many of these would it take to fill one of these? That's a nice little activity there, and you can work that one out. Now, get this. So there's something you can do on there. So do that on the activity sheet. And then what we're going to do is we're going to look at something a little bit, come on then. We're going to look at something a little bit more scientific. What we're going to do, and this is for more like 14 to 18-year-olds, but it applies to everyone. And this is super important. So anytime you're cooking, if a recipe says a certain amount of milliliters or a spoon, let's have a look. Whoa. So let's say it says a tablespoon, which it does. And then what do you have? You have just a spoon, half a spoon. In England, we talk about a tablespoon. In America, they talk about spoons, half a spoon, a quarter of a spoon, and then the cups. So the cups, I don't have an equivalent. Oh, I do. Do I have cups on here? I have cups on here on this one. I've got cups on there. So this will work for the Americans. But the thing is that if you say, well, I'll just use a spoon that's in the drawer. This is the measurement. When a recipe says a spoon or a tablespoon, that is the measurement. Now let's see if any old spoon fills it up. Can you see it's not filled up to the lip? It's a little bit empty. So if that's medicine or if that's a recipe and the amount of liquid is important or powder, you're not actually getting the right amount. And there's another one which is actually could be actually quite dangerous. Let me see. Let me get this one. Let me make sure you can see what I'm showing you. So let's say the recipe says 1/4 teaspoon, or even more importantly, the amount of medicine that you're going to give to a little person. And you go, well, for starters, we've got 2 teaspoons here. If we got those out of the drawer, we got 1/4 of this teaspoon. But well, that's about 1/4 teaspoon. I don't know. Well, what if you got 1/4 of this teaspoon? Oh, 1/4 of this teaspoon more or less fills that teaspoon. How much is actually 1/4 teaspoon? That is 1/4 teaspoon. Let's put it in there. That's how much it would be, but we don't want to guess, especially with medicine and with cooking as well. Sometimes the measurements are super important. When making bubbles, the measurements are super important. We don't want to guess. And so that's an area. And then you've got your pipette. So this one, let's see, 1 milliliter, 1/4 teaspoon is 1 milliliter. So in theory, if I fill this up to 1 milliliter, come on, you can do it. There we go. That should fill that. Whoa. That says 1 milliliter. You got to test your instruments as well. Make sure, there you go. It's brimming over, but it hasn't spilled over. So that's 1 milliliter. This is a really, really accurate way of measuring your medicine, not just medicine, but in the kitchen when you're cooking. And for me, for bubbles as well. Although for bubbles, sometimes you have to measure even more accurately. You need a really accurate scale to measure. So that was what the super important thing we wanted to cover there. And now let's see what else. And so that's, for example, when you have medicine, it's really important to use the cup that comes with the medicine, because that gives you the right amount of medicine. And so why are we doing this? So this is, there's an activity here to do some really accurate measurements. And it's important to not be estimating. And if you do estimate, you decide, well, I do want to estimate, like I just did with 1/4 teaspoon. 1/4 of this, remember, was totally different to 1/4 of that other little one. No, it's this one. 1/4 of that would basically fill that one. So it really matters. It's much more safer, more scientific to use proper measuring devices. And so do the activity for 16 to 18-year-olds. It's not a complicated activity, but it deals more accurately. Because, and then it might be a good time to talk about the difference between accuracy and precision, because you can be really, really, really precise. You can always get exactly 1 point, oh, it's dripping out. You can always get exactly 1.5 milliliters every time. Oh, look, I'm being very precise. 1.5 milliliters. And again, oh, get it right. Ooh, 1.5 milliliters every single time. Really, really precise, 1.5 milliliters. But guess what? We were supposed to have 0.5 milliliter, 0.5 of a milliliter. So you can be very precise and get exactly 1.50 milliliters every single time. But you can be completely getting the wrong amount. So you can be super, super precise. Like, for example, if you have a dartboard, you can hit your darts, and you can always hit your darts exactly in the same spot every single time. That means you're being very precise. But actually, you're out here and you're missing the bullseye. The bullseye's in the middle here, and you're missing because you're shooting exactly the same spot every time. You're being very precise, but not accurate because you're nowhere near the target. What you want to do is be precise and accurate, get right in the bullseye every single time. And then you'll get lots of points. Except for darts, you actually have to get all the different points, don't you? So you have to be, you have to be super precise with darts and get and aim it exactly the right place, that's a fascinating game, darts. Okay, so that is the activity we're doing. Now, why are we doing it? Why is this important? Well, real life, cooking, medicine, just any time, just make sure you get the right amount of orange juice. You don't get too little, and you don't want to get it too much, but also so that you don't think, you make wise choices. So you don't think, well, this container, which is bigger, this one or this one, actually, which is, I'm gonna test this one, which holds more liquid, the juice box or the plastic bottle? Let's do it over here. Let's find out. Whoopsie, it spills over. So this one holds, actually it says it on it, 330 milliliters, and this one holds 200 milliliters. And that kind of does look right. But there are times, like with the fairy liquid, that it looks as though it holds a lot more than it does. So that's one of the things in real life. And it's to help you think about capacity. And there's another point there. Capacity is not the same as volume. The capacity is how much fits inside a container. The volume is how much space it takes up. So if this is full, if it's solid, let's say, how much space it takes up. So if this was solid glass, we put it inside a bathtub or a big tub, we could be able to actually measure the volume without even having to measure it and calculate it, by sinking it down under the water and measuring how high the water went. So the amount of water that it displaces would tell us the volume, the amount of water, that the height of that water, the difference in the height of the water, we'd be able to calculate the volume. And or we could literally measure it, but that would be a bit hard with this. We can manage it, we can do it, but that's definitely for older learners. You can always estimate it though, can't you? And or you can make a mold. That's something else you can do. You can make a mold with plasticine or something, and then fill that mold up with liquid, and then measure how much liquid you've put inside, or measure it as you go in. So then you could calculate the volume by filling up the mold, and then you'd know what the volume of this container is. And if you want to know just the volume of the glass, then make a mold of including the blank out the inside, so you can then know exactly what the volume of just the glass is, or the volume of the whole container, in which case it would be hollow, and you'd be able to tell the volume of the whole container, including the handle. That's how you can do it. So it helps, you can learn this activity. You can learn how to read scales. You can learn the difference between 33 centiliters and this is 200 milliliters. Well, how do you say, well, which is more, 33 centiliters or 200 milliliters? And then this one is 1 liter. So it's getting used to all this one's now 820 milliliters. So it's like, make up your mind. And then on this jug, we've got 500 milliliters. We've got 5 pounds. We don't have kilos. That's interesting. 16 ounces and 2 cups. So it's converting between all of those. Hopefully you could see what I just did, because I was looking at the other thing. Could you see that when I did that? Yes, hopefully. Now go back to here. And it's about being accurate. It's estimating, comparing, ordering. We ordered it all, and then we estimated and actually measured it, and then calculating with volume and capacity. So we're thinking flexibly, we're being creative. You can come up with your own ideas. Last night, of course, with Leo, we had to get water everywhere. That was a requirement. And so that's fine. It's playing, we're playing, and that's wonderful. And then visualizing, estimating, super important. So and then developing practical skills. Even just the little thing of pouring water from one container to another without spilling it, and then also maybe pouring accurately so you get to the top and you don't spill any of it. This one's got some nice foam on top. At what point do you stop pouring? At what point does it actually spill over. Notice you have the dome shape on top. Oh, is it spilling yet? Hey, there it goes. Oh, I got my toe. All right. So if you're enjoying these lives, please do share them. Please do tell people, oh, look at that, we've got a bubble on top. Please do tell your friends about them, put a post on Facebook that grown-ups do it, and tell people about the Making Maths Fun for Kids of All Ages group. And then also we do have YouTube. We're going to do a YouTube live at about 10:30 with my friend Shane Scott from Australia. And we're going to do some really fascinating things with numbers. It'll increase your general knowledge as well as your number sense, and it's going to be super interesting. That's 10:30 today. And if you haven't already, if you search for on the Bubbly Maths YouTube channel, search for Fibonacci, and you'll find the video that we're doing later today. We're just going to do a live in 45 minutes. And yeah, and then there's the Maths Toys YouTube channel, which is because all these activities are from the Aiming High website from AIMSEC, and the Maths Toys YouTube channel, we are building up a reserve, building up a catalogue of videos where there's one video to match every home learning and inclusion guide that is being written for the Aiming High website to go with their teacher activities on there. So thank you very much for joining, and let's have a look, see who has joined us. Let's see what we've got here. I'm going to bring this down over here so that I can see you. Whoops. Oh my goodness. Okay, I've just spilt water all over the tripod. Let's have a look, see what we've got here. We've had, oh, hello, Rosalind. Long time no see. Russell Wells, hiya. Oh, more Stephen in Portugal. Helen up in I've got two Helens. My brain's gone. I think that's Helen in Scotland. Andy Davis, hello. Hi, I think this is South Africa, Londusine Diso in South Africa. Rosalind, Russell, Tommy Templeton, hello. And Salvo in Southend, hello. Thank you for joining us. And let's see if we did have, if it's still playing, if we did have any comments on the, ooh. I did play it, but no, it stopped playing. It's not playing. Oh, okay. Shane says, we do have some comments. Shane says, any bottle that is filled by a mechanical process. Oh, okay. This is definitely for the older learners. You ready? If you look at the comments, you'll see it. Any bottle that is filled by a mechanical process will have its volume as a normal distribution. And I have to fess up right now and right here, right now. That is something I haven't looked at since I did maybe my A-levels, maybe my O-levels back in the year. They don't even call them O-levels anymore. They call them GCSEs. So when I was 16, might have been the last time I thought about normal distribution, although I might have done it in my A-levels, which means I was 18. That's a long time ago. That was 40 years ago. So, oh, and Shane also said that there won't be a litre. Okay, but yeah, but we're filling it ourselves. See, we fill these ourselves. Shane reckons that there will never be exactly a litre when you buy it. It's always going to be a little bit more or a little bit less. Well, I hope there's never, yeah, a little bit over. No, he doesn't. He says there'll always be a little bit over a litre. But we buy this ourselves, and Leo insists on filling it up to here. And as we've discovered today, a litre is about here. So we always get quite a lot more than a litre. And presumably hopefully they include that in their price, in which case we're good with filling it up to there, because Leo insists on filling it up to there. But Leo does understand that we don't fill it right the way to the top. All right, well, thank you for joining us. And that's Shane is going to be with us doing the live. Shane's an amazing maths teacher. He's always looking for real life applications and being creative and and bringing maths alive. So I'm looking forward to the live that we're doing on YouTube on the Bubbly Maths channel in 40 minutes from now. So now I'm going to stop this live, and I've got 10 minutes to set up for the early years live. So ages 4 to 7, we're going to do activities. Summer's a little bit of a repeat. I'm going to get rid of the soap because that didn't help, did it? And I'll see you in a couple of minutes back right here for the early years live. And hopefully there will be no leaf blowers. Like all I've heard recently is hose pipes. So hopefully we'll be okay. Thank you, and see you in a minute. Bye.